Good morning, friend. Myself, Jitendra Kumar. I am taking the power electronics. Power electronics we already discussed in the previous lecture. So power electronics is a combination of two subjects: power plus electronics. Now the now we will discuss about the power diode. Power diode is basically a combination of again two words: power plus diode. Diode is basically you already studied in signal diodes. Signal diodes are operating on a low current and low voltage, but whenever we have to just make some changes in the diode in their structure, it will form a power diode. The power diodes are similar to a signal diode but have a little difference in its construction. As you know that whenever we are seeing or the simple signal diode, there is an anode and cathode are there. There is a p-type junction, there is a p-type layer and the n-type layers are there. Then again there is a drift region are there. But whenever we are saying about the power diode, there is a p plus depletion, there is a p plus and n plus layer are there, and there is in between there is a junction having a larger number of either the n type material or p type material. So in signal diode the doping level of both p and n side is same, and hence we get a PN junction. But in power diodes, we have a junction formed between a heavily doped P-type and a lightly doped N-type layer, which is epitaxially drawn on a heavily doped N plus layer. Hence, the structure looks as shown in the figure. So this will be the structure which we are getting in the power diode as compared to your the signal diodes there. The N negative layer is the key feature of the power diode which makes it suitable for high power application. As we know that the are operating on the low voltage and low current, but power diode are operating on a high voltage and high current. This will be the figure of the power diode whenever we are looking over this side. That we are getting that the external feature, external structure of the power diode is simple, and there is nothing will be the different from the simple diodes are there. But on a operation point of view, it will be quite different. This layer is very likely to almost intrinsic, and hence the device is also known as PIN diode, pin diode, where I stand for the intrinsic. As we can see in the figure of that the net charge neutrality of the space charge region is still maintained as was the case in signal diode, but the thickness of the space charge region is quite high and deeply penetrated into the N region. This will be the characteristics of the power diode. Over here you are find that the reverse recovery mode having a larger time as compared to the normal diode, and the forward convection region it will be quite lower than the simple signal diode. So there is a reason of this one. This is the forward convection drop are there, and this will be the reverse leakage current drop are there. So the reason over here where the power diode is operating, and whenever we are just compare about the signal diode operation are quite low as compared to this one. So the voltage and the current rating, and current it will be in the form of amperes, voltage again in the form of amperes, and the whenever we are just compare about the signal diode, the current in the form of a milliampere, and the voltage again in respect of the millivolt. So the total power that will be operating by the signal diodes and the power diode are quite different. The simple diodes are operating. The signal diodes are basically operate on a volt, on a watt or milliwatt, but the power diode are operate on from the watt to kilowatt rating. This will be the reverse recovery characteristics of the power diode. IF stand for the forward current, IRR stand for the reverse recovery current. So whenever we are looking over this side, that the power diode having the forward current magnitude is quite high, and as we are compare over the reverse recovery volt current, it will be equal. Both are the equal to, and the reverse recovery timing, it will be larger as compared to the timing of the forward current. So uh, the operation of this one, we are finding that the A plus B time associated for the movement of the forward towards the reverse, it will be TA, and the back time it will be larger as compared to the reverse of this one. These are the rating of the power diode where we are focusing over the voltage ratings, current rating, reverse recovery time, and the applications where we are using, and the remarks. General purpose diodes, which normally we are saying, general purpose diodes are the power diode. There is a rating of the 50 to 5000 volt. Current rating for the forward ampere, it will be a 1 ampere to several thousand ampere. Reverse recovery time, it will be approximately close to the 25 microseconds. And the application of this type of power diode are the UPS, battery chargers, welding machines, traction machines, etc. And whenever we are looking over the advanced form of the power diode, it will be called as a fast recovery diode. Fast recovery diode having the voltage rating will be lower as compared to the general purpose diode. It will be start from the 50 volt to 3000 volt, 1 ampere to several thousand amperes. The current forward rating current will be the same, but as the operation of the fast recovery diode, so we are the voltage it will be lower as compared to this one, and the reverse recovery time, it will be less than of 5 microseconds. And this type of power diode we are using for the SMTS, commutation circuits, chopper circuits, induction heating. The reason behind this one, that there is a doping done using the platinum or the gold. Schottky diodes are the another version of the power diode. It will be rating up to 100 volt. Current, it will be 1 to 300 ampere, and the reverse recovery time, it will be less than the nanosecond. And the application where we are using for this one, this type of diode is the very high frequency switching power supply and the instrumentation application. The remark for this one, that this type of Schottky diodes are used basically of a metal semiconductor junction, usually AI or SIN type majority carrier device are there, hence very low turn of time, so that it can operate at a very high frequency. It can easily operate. So this will be the operation of the power diode with their characteristics and the recovery, and the reverse recovery period will be mentioned over here. So this will be the end of your power diodes lecture. And thank you. Thanks for attending.